So we are in chapter 12 still. We should have finished it last time, but I'm just taking it easy a little bit because there's a lot of calculations in there and a lot of concepts. So today will be the last part of chapter 12. We can finish it as we can, and then we may use the rest of the class for a review for the exam. As you know, it is next Tuesday. And that is chapter 12 is not included, but if you understand or if you review also chapter 12 along with them, that will help you with chapter 10, because most of the default concepts that you are using here is the one that is a major concept in chapter 12. Anyway, last time we were talking about the limiting reagent. What is the meaning of a limiting reagent? It is the reactant that consumed first whenever we have more than two reactants. So when we have one reactant, like a case of a decomposition, there's no need for such a calculation. So if we have something similar to what you see in front of you here in this question, that we have iron, oxygen, and water. So if we were to calculate how many grams of iron hydroxide is produced, before we do that, we have to know which one of this will be consumed first, because that is the one that we will use in order to calculate the amount of the product. Because as you know, if we have, for example, this reaction, usually it occurs in a large quantities of water, and large, of course, in the atmosphere. So there's plenty of oxygen in there. If you use oxygen to calculate this amount, then your answer will be way higher than the truth. And that's why you have to determine first, which is, of course, by default here, it is the iron, but that's not the way to determine it. In order to determine the limiting reagent, you have to look for the number of moles available of each reactant. Or if you have the moles of one of them, you can go to the grams of the other one. So in this case, we have the 7 grams of iron and 9 grams of water. So the question is, which is the limiting reagent? Nobody can say iron because it is 7 grams. That is absolutely wrong. So what we did here is to use the 7 grams of water, change it into moles, 7 grams of iron, change it into moles of iron, then see how many moles of water we need to react with. That's why we multiply it by 2/2, and that is the ratio from these two here. Okay, so this way up to here, that is equal to the number of moles of water needed. But if we change that into grams by multiplying by the molar mass, then we get into the grams of water that is needed to react with all the 7 grams of iron. And turns out to be 2.26 grams. Because it is 2.26 grams, if you compare it to the 9, apparently that we have more than what we need of the water. And in this case, the one which will be consumed first will be the iron. So iron is the limiting reagent and water is the one which is in excess. Oxygen is not involved in the decision here because this is by default, because that happens in the atmosphere and there's plenty of oxygen. So this is, I know that this example we solved it last time. I just wanted to go over it again as a review for that part of the lecture. طيب. Moving on, the next and the last concept of chapter 12 is what we call percent yield. The percent yield is about how is the percentage of the amount produced. As I gave you an example last time, you are entitled in this course, every one of you is entitled for 100 points, which is your grade should be if you don't miss anything. If your performance is 100%, you will get, theoretically, you should get 100 out of 100, right? So this is actually what we call, this is your theoretical yield. Now, let's say for some reason or another, which is typical, you get 80%, 80 points. Your total points in this course became to 80 points. So how you calculate your score? You say the actual grade divided by the theoretical that you get, which is 80 divided by 100, multiply by 100%. To change it into percent, you have to multiply by 100, so that will give you 80%. So your score of 80% is what is called the percent yield. And that is, of course, in your case, definitely it is determining your efficiency in the reaction. So this in the course, I'm sorry. So the same thing applies to the chemical reaction. When we calculate, we have A plus B to produce C, okay? And we were asked to calculate how much C is produced. And when we do that, we do that calculation on the paper. We do not go to the lab and do the reaction. This is theoretical yield. So when we calculate this amount, that is what we refer to as the theoretical yield. So theoretical yield is the maximum amount of product that could be formed from a given amount of reactants. Always remember your grade if you want to remember this. Your theoretical yield is 100% because this is what we are giving you. We're giving you 45 points on midterms and 30 points on final, and we give you 15 on quizzes or whatever, 10 on lab and 10 on that and 5 on attendance. If you add those, that's 100. So when we say, what is your theoretical yield? Your theoretical yield is basically the 100%. But your actual yield is what actually you get. So the amount of product that you actually forms when the reaction is carried out in the laboratory is called actual yield. So the difference between actual and theoretical is this one is calculated in the paper. This is the actual one that when we run the reaction in the lab. And always, this one will be less than the theoretical. Always will be less. So the percent yield in this case is dividing the actual divided by the theoretical times 100%. And this is always also less than 100%. Because the efficiency of the reaction, the maximum it can reach is 100%. The same case as you. The maximum score that you get in this course is 100. Okay, you cannot get 101 because there's no 101 available. But what you get is 100, and that is the maximum that you can get. Here is the same thing. So theoretical value is the one that we calculated the maximum amount of that. Now you need to learn these terms, which is the maximum amount of the product that is produced. When you say the word the maximum amount, you understand that this is the theoretical value, because I will show you an example now that sometimes some of you will get confused. Which one is provided in the question? Which one is the theoretical and which one is the actual? First of all, the actual is always less than the theoretical. But sometimes one of them is provided, so you won't be able to compare, and you have to decide what you have in the question. Is it the theoretical or the actual? So using the maximum number of grams or the maximum amount means that this is the theoretical. And whenever we give you the actual value, then it says this is actually produced or produced. When we say this reaction produced, then this means that this is an actual value. Okay, so here's an example. The percent yield means the efficiency of the reaction, and that is again is what I already told you. When this girl here in front of you is running a chemical reaction or doing measurements and stuff like that, during the measurements there will be some the question is the following: why always the actual in the lab is less than the theoretical, which is in the paper? For several reasons. One of them is the reaction is not going to completion. يعني مش كل reactant, not all the reactant has reacted with each other and went to completion. That's the meaning of here. Okay, so you have A plus B to produce C, and theoretically all A should react with all B available and to produce C, but sometimes there will be some left here and there, not as an excess and limiting reagent. No, in general, there will be, the reaction is not completed. Impure reactants, when you weigh A, for example, you needed 2.65 grams, and you weigh it on the scale, which is very accurate, but that material is not pure. So part of the 2.65 that you weighed is impurities. So there will be less than what you put, and that will produce less amount. Also, the actual yield can be always lower than the theoretical yield due to the loss of the product during filtration transferring between containers. Assume that this product C here is a precipitate, okay? So in that case, if it is a precipitate, you have to filter it out using a filter paper. Then from the filter paper, you transfer it into a weighing paper after drying. And when you're doing this, transferring it from the beaker into the filter paper, and from filter paper after drying to the weighing paper and so on, you will lose some, and that will make the actual always less. Then the other one, or the last one, is a personal mistakes, which is when you were weighing the reactants, or when you weigh your product, you make some mistakes, and those mistakes are always in the lower side. Okay. Right. Here's the example that we will discuss today, which is calcium carbonate, your friend over here, the solid, which is found in seashell, is decomposed by heating. So the triangle here is for heat. The balanced equation for the reaction is that calcium carbonate produce calcium oxide and calcium carbon dioxide. What is the theoretical yield of calcium oxide? How many grams of this? When here it is very clear and straightforward. It says what is the theoretical yield. But in some other examples, some of them you're going to see today in the homework, which I will upload by this afternoon, so you can solve it over the weekend. You will see that sometimes it doesn't say what is the theoretical. It will say what is the maximum number of grams produced. Okay, what is the theoretical yield if we have 24.8 grams of calcium carbonate? So that's a straightforward, something that you have done first, which is what you need to do. What is the plan in this case? How you calculate the theoretical yield? Theoretical yield means it is numbers. I mean, it's grams. Actual yield are also grams, but percent yield is a percentage where you divide gram by gram, and it does not have a unit. It's a percentage, right? So what is the plan here? What we need to do? We have 24.8 grams of calcium carbonate, and we need to know how many grams of calcium oxide we can produce. So what we need to do, I'm asking a question here. Just give me a plan, what we need to run. I mean, how are we going to do the calculations? "28 grams of this from the mass to the moles." That will be 100 grams. Okay, that's the molar mass per 1 mole. Very good, yeah, Eileen. So we convert, or we change the grams into moles. Yes, that is true. And then after that, the number of moles of calcium carbonate, it happens here to be the same as the number of moles of that. But, for being following the dimensional analysis, we multiply it by 1 mole over 1 mole, just to be on the safe side. And that will give us the moles of calcium oxide. What is the last step will be that we multiply whatever answer we get with the molar mass of calcium oxide, and that will give you the theoretical yield. Okay, so here we have 24 grams. This is the molar mass of calcium carbonate. 56.1 of the calcium is the calcium oxide molar mass, and you do the first step. This is one of one, just to confirm that they are the same number of moles. And then times 56.1 grams by 1 mole, that is the molar mass of calcium oxide. So the answer is 13.9 grams. So if we run such a reaction, okay, with 24.8 grams of calcium carbonate, theoretically, on the paper, we should have produce, or the maximum number of grams that we can produce is 13.9. So this is your theoretical yield. Now, if you continue with this question, it says here, what is the percent yield if 13.1 grams are actually produced? See, this is the way you know that it is, this one is your actual yield. Either it will say actually produced, or it should say without actually produced. When we say produced or actually produced, that is mean that we're talking about the actual yield. So if your actual yield is that, what is your percent yield? And in this case, it is equal to the theoretical divided by the actual, the actual divided by the theoretical times 100%. So that will be 13.1 grams divided by 13.9 grams times 100%. That will be roughly around 94. Okay, so that will be 94.2%. It is less than, I'm wondering what is this, Eileen, that you put in there, which is 24 times 13.1 divided by 100. No. You made a mistake here, Eileen, and you have to review what you have done. The question says here that if we have, these are the 24.8 grams of the reactant, not of the product. So that is, following up the first question. So 24.8 is the reactant, not the product. And based on what we've done here, we know that what we get is 13.9. So your theoretical yield is 13.9, not 24.8. Okay, so what you get here is 94 dividing the actual by the theoretical, which you calculated in the previous question. Okay, let's take the last example over here, which is carbon tetrachloride. This guy here, CCl4, is a solvent that once used in a large amount dry cleaning. One reaction that produces carbon tetrachloride, so there are many other reactions that can be used to produce carbon tetrachloride, is this reaction, which is reacting carbon sulfide with chlorine to produce that. What is the percent yield of CCl4 if? That's what I was referring to. Now you will get somehow confused unless you read it the way I ask you to. What is the percent yield if of CCl4 if 617 kilogram is produced from the reaction of 301 and 12 kilogram of CS2. So first of all, he is telling you that CS2 is the limiting reagent. He did not mention the chlorine because that will be in excess. Okay, so you're going to use this amount, which is the 312 kilograms of CS2 as the reactant. So we have here 312 kilograms of this, and the 617, is this the theoretical yield or your actual yield? Based on what you read from the question, this is your actual. And that is because it says 617 is produced. Sometimes it says actually produced, or sometimes it says it produced. So the percent yield, as you know, is equal to the theoretical divided by the actual times 100%. So do we have the theoretical? No, we don't. So we have to find this out. Do we have the actual? Yes, that is 617 kilograms times 100%. So we need to find the theoretical first, and that is typical. So we have here 312 kilograms. We change it into grams first, and then we multiply it or by 1 mole over the molar mass of CS2 to get into the moles, and that is equal to the number of moles of calcium of carbon tetrachloride. Then we just multiply it again by the molar mass of that. So here's the amount that we start up with, the CS2, which is 3.12 times 10 to the 5 grams, multiplied by 1 mole over 76, and that is the molar mass of CS2, multiplied by 1 over 1 mole over 1 mole, just to confirm that these are the same number of moles. Then times the molar mass of CCl4, that will give you the number of grams of CCl4 theoretically produced, which is equivalent to 630 kilograms. So we divide the 617, the actually produced, divided by the theoretical times 100%, and this way we get into the answer that we're looking for. 97.9. If any, for any reason, in any question that you get an answer which is more than 100%, immediately know that you are exchanging the actual with theoretical. You're using the wrong numbers, okay? Because it cannot be more than that. This is the end of chapter 12, okay? And we still have time, so I don't know how we can run. First of all, do you guys have any question on this, on the actual, the last part? Which is the last part? Be specific. Is you mean this one here, or what I said toward the end? If what I said toward the end, I said if for any reason you get an answer here that is more than 100%, then always, we said that the actual is always less than the theoretical. So if it happens that in any question that you make a mistake, تخيل إنه somebody made a mistake and he put 630 divided by 617, then he's going to get something like maybe 105%. So that is wrong, absolutely, because the efficiency of a reaction is always less than less than 100%. It's like, again, your scores are always less than 100%. Nobody will get more than 100%. Okay? Did I answer your question, Yadania, or do you want me to repeat something else? Because what we did here in front of you, all of this is something, nothing new in here. All of that, we have done it several times. The only new thing is this one, and it is depending on your understanding of the question. Most from my past experience with this type of question that is related to calculating the percent yield, I noticed that most of the student mistakes are related to identifying the numbers provided in the question. Like this one, no, the 300, some of them, there are plenty of mistakes, but some of them, they think that the 312 is one of the values that they can use, either theoretical or actual, which is absolutely not right. Okay, so I'm not sure if you guys, I will post the homework for this chapter on the Moodle today, and you should be able to resolve it or do it between today and Saturday as usual. Now, Sunday, hopefully I will be in campus. I will let you know on Saturday for those who are interested to come. And we will start chapter 14. But today I will give you the chance for any review that you guys would like to do for chapter 10 and for chapter 11. Do you have any questions that I can help you with? No? No questions? Maybe you're thinking? طيب, I can give you some advices, regarding chapter 10. Well, first of all, you guys are lucky that we only have chapter 10 and 11 in the exam. Usually we include chapter 12, and that will make it, a little bit harder because there will be many things that we can ask about. In chapter 10 and chapter 12, if I'm in your position, I would focus on every concept that we have learned, because since we have a limited number of topics, then indeed we're going to put at least a question in each concept. And just put yourself in our shoes, as they say. And for example, how to balance a chemical equation, how to write a complete ionic equation, how to write a net ionic equation, how to determine the spectator ions, how to what else? Write the we said the ionic equation, complete ionic equation, balancing a chemical equation, writing a chemical equation. Um, um, what else in chapter 11? Then after that, determining whether a precipitate will form or not, determine whether a single replacement reaction will happen or not, determine the type of reaction. So the 5 reactions that we gave you, you should be aware of their types. And if we give you examples on that, you should determine their types. Now in chapter 10, the majority of the calculations, or all the calculations that you may have, will be on changing from grams into moles, as you already said. This has become by default, so you should be able to do it at any time. Grams to moles, moles to grams, number of moles, number of particles, volume under STP, these kind of the concept of the conversion factors in general. And what else? What other calculation? We talked about the density, and that is the mass over the volume. So whenever we know the volume of a gas, and we can determine either the molar mass, or from the density we can determine something else. Oh, one other important thing, you remember the empirical formula, empirical and molecular formulas. That is for sure we have questions on that. So if you were to, the way I'm listing the topics to you now is basically, I'm trying to show you how to review for the exam. Before Tuesday comes, you should ask yourself all these questions that I already listed. Do I know how to balance a chemical equation? What is the meaning of a balanced equation? What is the meaning of a spectator ion? Can I identify them? Uh, what is the meaning of a complete ionic equation? Can I write it? How can I do that? What is an ionic equation, and how to determine it? By removing the spectator ions. Something like that. Keep asking yourself these questions, and go over all the topics. Don't leave any topic without making sure that you understand. And I'm very sure if you do that the right way, you'll get a good score. I'm not gonna say you get 100%, because some of you will still make some mistakes here and there, but inshallah every one of you will do good. Okay. هذا اللي سأل عنه يا دانيا، كل اللي قلنا لك اياه. سأل انه في بونص ولا لا. I don't know. مش شايف في حاجة للبونص. I don't see a need for a bonus. بس بنشوف. تعرفين احنا بنحبكم كثير، فلما بنشوف الوضع متدهور بنعاود نساعدكم ببونص، بس ما تعتمدوا على الكلام هذا. أنا شخصيا ضد البونص، لأنه some students they will start depending on it. لما يكون يحل في الامتحان بيصير يقول لحاله اوكي انا عندي 2 question bonus، خلي هذا السؤال مش عارف احله، the hell with it. هذا اللي انا بحبوش في البونص. انتوا طبعا بتحبوا البونص all the time. بس to answer your question, Dania, I don't know, because we did not put the exam yet. Some of you might ask about the number of questions. How many questions are we going to have? Maybe 25, maybe 30, because we still have a room to have a 30 question in 1 hour, as most of the questions will not be calculations. Next time when we do chapter 12, 14, and 17, which is 100% calculations, all of them, the number of concept. Can we revise how we know if a precipitate is formed using the table? Yeah, we can, Dania. Well, again, that table, need to be memorized somehow. But if I'm in your position, I will not just memorize it as it is. There's a difference between memorization and all that. Let me try to share with you if I can. Yeah. I have to open, which chapter is this? Is it chapter 11, right? The last part? Sorry. Let me see. I have to share with you this one. I'm not sure if I can open it. All right, this is here. We have chapter 11 and we have lectures. Let's see, if you're lucky, it will be here. Now, can you see this? Yeah, Ghaida Udani. Can you see the presentation of 11.3? No, that's what I thought. عشان هيك. طيب, let's do another new share. Okay. Yeah, here it is. Now you can see it, right? Okay, good. طيب, let's take you to that table, yeah, Dania. Okay, here we go. All right, now, first of all, you need to understand that forming a precipitate will occur whenever we have an ionic compound that has cation and anion, and those are, when they combine, they will form a precipitate from a double replacement reaction. So basically we have Rs plus Tu to produce what? R will replace T, so that will be RT plus شو اسمه plus TS, right? Now the question is, طبعا هذولا TU والRS, both of them are aqueous. يعني هذولا they will be, can be written as cations and anions. One of those might be يا TS يا RS, might be a precipitate. In order for you to decide, you have to look at sometimes at the T. For example, let's say we are investigating TS. But we have sometimes to look at the cations, sometimes we have to look at the anion. For the cations, if it is from group 1A or ammonium, then it is soluble. Okay? So anytime you have a cation, like potassium, lithium, sodium, all cesium, all of these in the first group, they will be soluble. And if it is ammonium, like NH4 plus, then it is soluble. طيب. The second thing, the second part, طبعا هون بقول لك exception is the lithium. I'm sorry. Lithium compound are exception from that. I can tell you that يعني such an exception usually بنسألش عنه. طيب, okay. This exception, مش أي exception. في exceptions هون, they are very important as a matter of fact. Okay, so if we go to the second one, which is anything with NO3s, nitrates, NO3 minus, يعني S, and we are investigating the S. If it is NO3 minus or chlorate, which is ClO4 minus, then in that case, that is also soluble. طيب, sulfate, SO4 minus. SO4 minus compounds are, in general, they are soluble, except if they are with lead or silver, mercury, barium, strontium, and calcium. So calcium sulfate, strontium sulfate, barium sulfate, lead sulfate, silver sulfate, mercury sulfate. All of these are insoluble. They will form precipitates. The chloride salts, they are soluble except these three. طبعا احنا أخذنا examples على halogens in general that whenever they are combined with silver or with lead, they are actually precipitate, and with mercury. Otherwise, they will be soluble. يعني sodium chloride, for example, NaCl. ليش NaCl is always soluble? First of all, لأنه Na is from the alkali metals, which is group 1A. The second reason is that it is chloride, and the chlorides are soluble except if they are with silver and lead, and this is not silver and lead. Now, this is the majority of the precipitates, which are the carbonate, phosphate, chromate, sulfate, hydroxide. All of these are insoluble. طبعا وقتيش بصيروا soluble إذا كان السولت is with the cation that is from group 1A. مثلا sodium carbonate is soluble. ليه؟ لأنه sodium CO3 NaCO3 Na2CO3 لأنه الصوديوم from group 1A. بينما الكالسيوم كربونات is precipitate. ليش؟ لأنه الكالسيوم is from group 2, it's not from group 1. اوكي لو تاخذ مثلا الهيدروكسيد، اوكي potassium hydroxide KOH is soluble, you know that. Sodium hydroxide is soluble also. بينما الكالسيوم hydroxide or magnesium hydroxide, they are insoluble because they are not from group 1A. So this is the way you can يعني the more you go over this table, the more you memorize it. And yes, there will be some questions asking you about whether a precipitate will form, which of the following will form a precipitate. Yeah, and it depends on the combination that you are going through. All right. Did I answer your question, Dania? No? MashaAllah. What do you mean no? You said revise it with us the table, and I did. Why are you saying no? You thought I'm asking you, do you have questions? Okay. All right, maybe. All right, any other questions or concerns? Now, what I'm trying to do here with the review is to tell you what you need to focus at. All the topics that I mentioned need your attention. They needed your attention because, as I said again, the exam is covering only chapter 10 and chapter 11, and this is kind of a limited number of topics. So basically, if we were to put 30 questions or 25 questions, then definitely we're going to go over most of the topics that we have discussed. مش زي final exam في 11 chapters بتصير يعني you do pick and choose. Here يعني you have to cover all the topics that we have discussed, and that's typical for a midterm exam. Okay, if you don't have any question, we can close the session and we'll speak to you inshallah, and hopefully we'll see some of you on Sunday. All right. All right, enjoy your weekend, and remember that I told you that I will put the yes, you need to focus on everything, Nora. I will inshallah put the homework, and you guys should do it over the weekend. Yalla, see you inshallah. Salam.